This brief talk will discuss the case for STEMS. STEMS is formed by adding an S at the front of the acronym, in which it aligns all the other letters in the sequence in terms of a new product development. It provides a context, heightens the societal importance of STEMs, and it's a pathway to discussion of a career in the STEM disciplines. The societal need, the voice of the customer, is captured by market research, in which you end up embodying the voice of the customer into products by industrial designers. Industrial design is concerned with aesthetics and ergonomics, and of course, the aesthetics aspect involves the arts, sculpture and painting and ads and such like. The upper grouping of bullets it just walks through the various grouping of the STEM disciplines, in which they're just multidisciplinary. The order is not important, as was indicated. It originally was SMETS. And so there's no particular reason for studying these disciplines, which is evident or needed by this sort of grouping. The lower piece discusses the fact that the STEMS process is an interdisciplinary process, and the first is the society, which drives everything and provides a purpose, and the subsequent disciplines are in the order of a new development process. Of course, it's not a linear process, because all the disciplines are interactively linked together in a design process, in which each element affects all elements. As the last slide discussed, new product development is an interdisciplinary design process. It's larger than just the physical product, because it requires integrating the various functional departments across the organization to develop the product design. That involves an iteration amongst these various functional departments and trading off the voice of the customer, top-level requirements, with the design for manufacturing, design for assembly, and of course the supply chain design. It's important for children to understand the product and process design process and how all the aspects fit together, both as a career choice and the relevance of academic courses that they'll be taking. As an example of the design process using STEMs, we'll consider a bicycle, in which we begin on the left-hand side with the societal need for human-powered transport. In the past, there's a column, the next column shows all the various historical choices that are available, or have been available, and still are today. And then the slant arrow going from the societal need up to the functional requirements, and that column shows a listing of the various kinds of functional requirements that are required. For each one of those requirements, you apply some sort of a technology, which is the next block along. And in this case, we're looking at the braking requirement with a 5-pound grip hand with your hand. That will be done with, and typically is done, with levers, the hand grip, and at the calipers, grip the rim of the wheel, and a wire connecting the two lever components, in which you obtain a mechanical advantage, which stops the bicycle. Now, the engineering aspect in that column requires the sizing and the shaping and the choice of the material such that the components don't break. And in that case, you usually use some sort of a structural factor of safety. And of course, you also have to consider the cost to produce the various parts. Engineering uses mathematics, like in the stress analysis programs, and science, which is based on the material elastic property laws. In this diagram, engineering is sort of shown as a sort of integrator of all the various other disciplines in the STEMs disciplines. The societal needs are converted into an industrial design, which primarily captures the man-machine interface and interaction, and it's an external design, having to deal with external aspects. The other disciplines that engineering deals with is that it takes the industrial design and then it has to work through and select the various subsystems, the mechanisms and the various linkages amongst the subsystems with the mathematics and science, as I mentioned earlier, to design a product, and then also the production and the supply chain design. This slide just lists the sort of high-level benefits of using the STEMS acronym. It helps parents, students, and teachers understand how the various disciplines fit together in terms of the design process, involving iteration and reaching an optimized solution. It gives the answer to the why you have the disciplines to satisfy a societal need. It emphasizes the importance of the arts in industrial design. It talks about how the functional departments have to operate in an industrial enterprise. It helps students make a more informed career choice and provides a larger context of the various individual courses that are needed in order to perform properly in your career. And there is, therefore, some sort of relevance of this STEMS acronym to the NAS educational framework.